This is SpaceTime, Series 28, Episode 51, for broadcast on the 28th of April, 2025. Coming up on SpaceTime, the danger of coronal holes in the Sun. Crystal clues on Mars point to a watery and possibly even life-supporting past. And NASA's Lucy spacecraft successfully completes its close encounter flyby of the main-belt asteroid Donald Johanson. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has shown that coronal holes are spraying solar wind across the Earth and the rest of the solar system like a garden hose. A new study published in the journal Scientific Reports has discovered that these vast magnetic windows in the Sun's corona are launching fast solar wind streams into space at supersonic speeds, shaping their flow throughout the heliosphere. Right now, planet Earth is being bombarded by high-energy particles originating from a massive coronal hole in the face of the Sun. The new findings are setting the stage for the upcoming Vigil mission, which will station a sun monitoring observatory in the Lagrangian L5 position. Vigil will be a dedicated solar sentinel monitoring the Sun. It'll help transform deep space observations into unprecedented early warnings of solar storms, protecting critical infrastructure on Earth and in orbit. See, the problem is the Sun doesn't just shine, it blows. There's a relentless stream of charged particles known as the solar wind, which are constantly surging out from the Sun at hundreds of kilometers per second. This flow of solar wind particles drench the Earth, and in fact the entire solar system, in a flood of electrons, protons, and helium nuclei. When the particles reach the Earth, they slam into the planet's magnetosphere, causing the shield to wobble like jello. Now, if the stream's strong enough, particles can penetrate this protective shield and then flow along magnetic field lines, triggering the spectacular northern and southern auroral light shows known as the aurora borealis and aurora australis. But they can also damage spacecraft, shorting out delicate electronics and causing the atmosphere to bulge out, adding extra atmospheric drag to spacecraft, resulting in orbital decay. And that forces mission managers to use up the limited fuel supplies aboard these satellites in order to maintain their operational orbits. These solar storms can also affect communications and navigation systems. They can black out terrestrial power grids, and they can increase radiation exposure for astronauts and even people in high-flying aircraft. For much of the time, the solar wind's a smooth breeze, but it can turn into a turbulent river with fast and slow-flowing currents depending on the strength of solar flares and geomagnetic storms. And we now know the fastest streams of all come from coronal holes. These are dark, cooler patches in the Sun's outer atmosphere, areas where the Sun's magnetic fields stretch open and high-speed solar wind streams can escape into interplanetary space. But exactly how these holes shape the solar wind's behavior is still an open question. In fact, when high-speed solar wind streams collide with slower-moving solar wind, they create massive structures called co-rotating interacting regions, and these spiral outwards as the Sun rotates. Now, the Sun's a big ball of gas, and different parts of the Sun rotate at different speeds, with the Sun's equatorial regions rotating roughly once every 27 days. And so a single coronal hole can bombard Earth repeatedly, creating a celestial maelstrom of space weather. And that's where this new pioneering study comes in. It's revealed how coronal holes propel these fast streams of charged particles. The research also delivers a major advance in space weather forecasting, extending prediction lead times from hours to days. Using a unique observational vantage point at the Lagrangian L5 position, which is 60 degrees behind the Earth as it orbits around the Sun, scientists can now better predict when these solar winds reach our planet. The study's authors solved a key problem: why the solar winds measurements differ between L5 and L1 observatories, L1 being directly between the Earth and Sun. They traced the variations to three critical factors: the combined effect of smaller coronal holes, their precise locations on the Sun's surface, and the latitudinal position of spacecraft detecting the solar wind. These findings underscore the importance of future missions to both the L4 and L5 positions, missions like ESA's Vigil, which will improve early warnings for geomagnetic storms, helping protect satellites, aviation and power grids from disruptive space weather events. The new study shows that this effect is more pronounced for smaller coronal holes at higher solar latitudes, and it depends strongly on the latitudinal separation between spacecraft. In contrast, larger coronal holes are delivering solar wind more uniformly across the heliosphere. The findings will not only improve space weather forecasting, it'll advance science's fundamental understanding of the solar terrestrial environment, and it will also underscore the importance of continued exploration from diverse vantage points like the L4 and L5 positions to fully unravel the Sun's influence on the solar system, in the process enriching the broader field of heliophysics and space exploration. This report from ESA TV.
It's the first of its kind. Keeping a constant eye on our star, it will help protect Earth from the Sun's violent outbursts. Introducing ESA Vigil. ESA's newly named space weather mission will fly to a unique, gravitationally stable position trailing 150 million kilometers behind Earth. From here, it will survey the side of the Sun, as well as the space between the Sun and Earth, reporting home in real time. ESA Vigil will help spot sources of dangerous solar activity before they rotate into view from Earth, as well as tracking enormous explosions that could severely disrupt satellites in space and infrastructure on the ground, threatening the health of astronauts in space or, in the future, on the Moon. Sunspots and active regions, dark patches on the solar surface, can erupt with solar flares that release tens of millions of times more energy than a volcanic eruption on Earth. Flares emit energy across the electromagnetic spectrum, from low-frequency radio waves to visible light, up to high-energy X-rays and gamma rays. Coronal mass ejections are giant explosions that shoot billions of tons of plasma from the Sun in magnetic clouds that dash through space at up to 3,000 kilometers per second. Processes associated with solar flares and coronal mass ejections can also accelerate particles in the solar wind to near light speeds. Sometimes, this high-energy matter, radiation and plasma is directed at Earth and arrives with an almighty bang. When coronal mass ejections strike, they can cause major disturbances to our way of life, disturbing and damaging satellite operations, power grids, aviation, navigation services, transport, weather services, and telecommunications. Solar storms even pose a radiation risk, threatening astronauts in orbit and aircrews flying over the poles. Data from Vigil will stream into ESA's Space Weather Service network, where it will be processed into practical information and shared quickly and freely, giving us time to act. Named Vigil from the Latin Vigilis Acceptus, meaning sentry, and Vigilia for wakefulness and keeping a devoted watch, ESA Vigil will soar into the dark skies, keeping a constant, careful eye on the Sun to help protect our modern lives and even life itself.
This is SpaceTime. Still to come, crystal clues on the red planet Mars are pointing to a watery and possibly even life-supporting past. And NASA's Lucy spacecraft successfully completes its close encounter flyby of the main-belt asteroid Donald Johanson. All that and more still to come on SpaceTime. This episode of SpaceTime is brought to you by Incogni. Just because we're exploring the vastness of space doesn't mean there's not a lot happening here on Earth as well, especially when it comes to your personal data. See, every time you sign up for something online, every time you search for a product on the net, or even just browse the web, your data is being scooped up by companies called data brokers. Now, these are folks who collect, buy and sell your personal information, often without you ever knowing. And that's where Incogni comes in. It's a powerful hands-off service that helps you take back control by getting your data removed from the databases of those brokers. And they do all the legwork, sending out official removal requests, following up and making sure your information actually does get deleted. It's simple, it's effective, and it's a big step towards reclaiming your digital privacy. And right now, SpaceTime listeners can get an exclusive 55% off their Incogni subscription with a 30-day money-back guarantee. So just head over to incogni.com/spacetime. That's incogni.com/spacetime. Incogni. A new study has shown that water was once widespread across Mars. The findings, reported in the journal Science Advances, are based on the virtually ubiquitous spread of calcium sulfate minerals on the red planet's surface. The authors analysed data from NASA's Mars Perseverance rover using a new analytical method called X-ray backscattered diffraction mapping. It uncovered compelling evidence of multiple mineral-forming events just beneath the Martian surface, findings that are bringing scientists a step closer to answering that profound question of whether life could ever have existed on the red planet. The study's lead author, Michael Jones from the Queensland University of Technology, says the evidence shows sulfate minerals exist with different amounts of water in most regions across Mars. And this allows scientists to understand how water moved around the red planet, which is key to understanding its past habitability. However, Jones and colleagues didn't fully understand yet how and when these minerals were formed. So, they found a way to measure the internal crystalline structure of these minerals directly in the rock, which was thought to be impossible on the Martian surface. They did this by adapting X-ray backscattered diffraction mapping developed at the Australian synchrotron to work with the Perseverance rover's onboard pixel instrument. This allowed the authors to determine the orientation of the crystal structures, essentially providing a fingerprint of how and when they grew and what the environment on Mars was like at that time. Two separate generations of calcium sulfate minerals were discovered, one at Hogwallow Flats and the other at Watery Pass, both in the Shenandoah Formation, which is part of the sedimentary fan in Jezero Crater. One was formed just below the surface, and the other formed deep underground, at least 80 metres down. Jones says the discovery highlights the diversity of environments that existed in the Shenandoah Formation's history, indicating multiple potential windows when life may well have been possible on the Martian surface. Since its landing in Jezero Crater back in February 2021, the car-sized six-wheel Perseverance rover has been exploring a wide variety of Martian rock types, from ancient lava flows through to sedimentary layers left behind by a long-vanished lake and river delta. Jones says that one of the key mission goals for Perseverance is to study environments that could have supported microbial life and collect samples that may one day be returned to Earth.
So this started as a question that I had with a colleague, Christoph Schrank at QUT, where we really wanted to map mineralogy in rocks. So what we wanted to do was we wanted to find out how fluids move through the deep crust. And this is an important thing for Earth, for minerals, for resources, all sorts of things like this. Also for things like nuclear waste disposal. But in order to examine these rocks how we wanted to examine them, we had to develop some new techniques because the techniques just weren't available that allowed us to map the mineral grain direction alongside trace elements. So we developed this method, which we called X-ray backscattered diffraction microscopy, because we love acronyms, and if they have an X in them, then even better for X-ray stuff. And then as part of the work on the Mars rover, we see diffraction in the pixel instrument, and the pixel instrument was designed to detect fluorescence, so we could map out trace element and bulk rock chemistry on Mars, so we can not only see what elements and minerals are on the surface, but how they are interlocking together or working together. And this proved really important early on in the mission, when one of the main outcomes was that where the rover landed on Jezero Crater, Jezero Crater is thought to have been an ancient lake, and the bottom is very flat, and it's actually a lot shallower than it should be based on its diameter. And so the initial thought was, this is sediment. It's filled up with sediment. There's what looks like a river flowing into it with a delta. All signs pointed to sediment. And then when we landed, you start to wonder these things. And of course, as scientists, you always question what something is. And by using this mapping out of the elements combined with mapping out some diffraction that we could see, we actually worked out that the floor was actually an old lava floor. Essentially, the floor was lava, not a sediment, which of course threw everyone for six. But this is one of the main outcomes of this instrument.
Yeah, the sediment was all stuck on the delta itself, wasn't it?
Yeah, the sediment's all in the delta. So, it's, of course, one of the really interesting things about working on Mars is that you've got something that over the last few billion years, you've just had dust erosion from it, from a very light breeze blowing around the planet. You think, as if the dust is going to blow around that much. But over a few billion years, you can erode kilometres of sediment very easily. So the question is always, we have this delta coming in, which is a sedimentary delta over the top of this lava. And so did the lava come first? Did the lava come second? Has all the rest of the sediment just blown away? And what was the extent of the sediment on the top? And so when we got to the front of the delta, we mapped at the very base 2 little outcrops of rocks. And to map, we have a little abrasion bit. And so we scrape the surface about the top centimetre of rock off. And we get a little circle, which is actually only 5 centimetres in diameter. So we're getting quite a small window. And we did this on 2 outcrops, which are at about the same elevation and very close to each other, so within 100 metres or so. And so because they're at the same elevation and it's a sediment, the logical thing is that these formed at roughly the same time. So these rocks were deposited at the same time, they're at the same elevation, sediments form these nice layers, and everything points to them being part of the same layer of sediment. When we mapped them with Pixel, we found that the calcium sulfate looks different in both of these little abrasions that we looked at. In one of them, we found these shapes that looked blobby, some straight shapes, some round shapes, one that looked a lot like a fish, and we, of course, termed it a fish. And in the other one, we found a very fine crack. And this crack has a very distinctive shape, and the shape is of a wing crack. These wing cracks form from a large stress on the top of a rock. So a solid rock, we have a lot of weight on the top, and we have liquid that's trapped in this layer of rock. And as the pressure increases, it cracks. And then because it's underground and we can't just have empty space.
Is this different from moisture in the rock simply expanding, contracting with temperature that's causing the crack? This is a different process.
This is a different process. So this one, that is this fine wing crack, is based on just the geometry. We hypothesize that it is this stress crack that's formed, that cracked because of a huge weight of material on top of it. And then the liquid has been sucked into this space, and as it gets sucked in, the salts solidify, and they solidify in a very distinctive way. And so by then applying this XBDM technique that we developed at the synchrotron, we had to make adaptations, of course, for it. We found out that the calcium sulfate grew in this crack is exactly what we would expect from this to be a crack that has been buried under a lot of rock. And this crack formed in a solid rock, so it didn't form in a sediment. In contrast to the first patch that we looked at, where we had these blobs and different random shapes, when we imaged the calcium sulfate crystals in this patch, we found that they just formed little randomly orientated small grains of calcium sulfate with no real alignment and no indication that they formed under any particular stress. And so this, combined with the more random shapes of the cracks, is more indicative of this forming from a mud that essentially dries out and is wetted over time. So this is what we call a shallow subsurface crack system. And so this formed very close to the surface, within a few metres of the surface, and was filled with this sulfate, but not in a way that is driven by some external stress. And so essentially from the method, we find these two regions which were deposited at the same time, but they were filled with these calcium sulfates at very different times in their existence, in the history of Mars. So one of them was filled, we would assume, not long after it was deposited. And then the other one was actually filled with calcium sulfate after at least 80 metres of rock was on top of it. And this 80 metres of rock has since been blown away by the gentle breeze on Mars over a few billion years.
It's not like the movie Mars, where you've got these huge, powerful winds. This is all because of the density of Mars, the lack of density in terms of the atmosphere. These are all very light processes.
Yeah, it's really, really slow. And the interesting thing about Mars that you always have to remind yourself is, for starters, there is no tectonic activity, or hasn't been for a very long time. So the surface that you see now is the surface that's been there for a very, very long time. And that even a gentle breeze can do an awful lot over a few billion years. It's a very long time. To gently blow on a rock, you do erode away a rock.
Grain by grain.
Yeah, one little grain at a time. And then they get blown onto the rover, and this is why we no longer use solar panels.
The work itself must be fascinating.
Yes,
You're playing on
very
another planet.
exciting to be involved in. Yeah.
What's that like?
It's exciting and stressful. I would say, at the same time. At one point, you're dealing with things that have never been seen before, never been done before, and you're really part of a huge team that is driving the direction of the research and where you want the rover to go, what you want the rover to look at. On the other hand, you're asking for someone to move an instrument on another planet that costs billions of dollars to within 1 centimetre of the surface and zap around on the surface, which is incredibly stressful as well. And you're always aware that at any moment it doesn't take a lot for it to go wrong. So there's a lot of stress, but there's a lot of a lot of exciting things. And also this big team of scientists all working together allows you, I suppose, the sounding board and the collaborations to open up, to spend time on these sort of methods and apply them and get these things working in a way that in a more isolated research environment on Earth, you might not have the time to do this.
The rover Perseverance has now moved to the rim of the crater. In fact, it's been in the Witch Hazel Hill area of late, and they found some fascinating rocks there, and all very different. Instead of traveling for days, sometimes weeks, to find a good rock sample, everywhere you turn, there are new rock samples that are completely different from ones next to them. That must be exciting too.
Yeah, the climb up the rim was long, slow and boring. It was essentially like climbing a very large sand dune, and then we go over the other side of the rim, and the rocks are so vastly different to anything we've seen in the sedimentary delta and on the crater floor. They've been altered in different ways. They've had a different history of water, and it's really intriguing in a lot of ways. And one of the ways that this is actually very, very, very intriguing is these rocks are very different to what we find in the sediment in the delta. The sediment in the delta must have come from upstream, but it didn't come from these rocks immediately outside of the crater rim. So where did this sediment come from? This is a huge question.
The loss of Ingenuity must have been a big blow.
Ingenuity was absolutely amazing.
It was only a test, I know that, but it proved to be so useful.
It was, as you said, designed just to test the possibility of flying something on another planet. This is the first thing to take off and land on another planet under its own steam. So this is absolutely incredible. And it did it for so much longer than thought. And more than just a test, it actually gave a perspective that we never had before, and that is incredibly useful. And if you just imagine that you're in a landscape where there is no vegetation, and so your sense of scale is completely blown. You have no trees to say this rock is 1 meter high and really close, or a kilometer high and a long way away. And we're sitting on a rover, and the highest camera is about 2 meters. It's like essentially standing on the ground, and you're looking around and you're trying to map out where to drive this rover and what looks interesting up ahead. And previously we had to base all of this on what we saw from orbit, which is
resolution issues.
Good. Yeah. And so now all of a sudden we could essentially send a little helicopter up to take photos and plan our journey and see things that we would have so easily otherwise missed. So an interesting rock in a slight depression that we can now see because we have the perspective to see it. It was really groundbreaking work.
Wherever you have an atmosphere now, you're going to have these little drones flying around the place. That's definitely the future of space exploration on another world.
Yeah, we are already thinking.
Yeah, more for Mars, and also when they do the sample return mission, they're looking at a few. And also, of course, the mission to Titan.
Yeah, these are all amazing. The sample return mission, if we could include a drone with some of these instruments like we had on Perseverance. And the pixel instrument on Perseverance is actually, for an X-ray microscope, people think this must be huge. It's about 20 centimetres by 20 centimetres, and it weighs a kilogram or so. If we could cut that in half again, we could potentially mount that on the bottom of a helicopter and just fly to where we want and land an image when we land and fly to another place. This would be absolutely amazing. We can do this with a lot of different instruments, to miniaturise them, and the sky is the limit, or the research funding is the limit, really.
Looking at the satellite images, can you make a determination where these different calcium sulfates would have come from?
So these calcium sulfates, we see them everywhere on Mars. This is something that is slightly different between Mars and Earth. These are not common products on Earth, although essentially calcium sulfate is gyprock, which most walls are made of. But we don't see it in the same way on Earth. On Mars, this is essentially carried in the water around Mars. So the calcium sulfate gives you clues as to when and where the water was and what the water was like. So this has been moved around the planet, essentially in flowing water, because of course if you evaporate and rain, you don't take the salts with you. So this has been moved around the planet in flowing water, and this is everywhere. So Curiosity on the other side of Mars sees the same calcium sulfates. Yeah, there's the same calcium sulfates there. They've been the same that Spirit and Opportunity saw. At the poles, the same calcium sulfates. So this is something where we have this water flow around the whole planet, like the oceans on Earth.
Mars was once a very warm, wet world, almost an ocean world, judging by the geological evidence we're seeing.
Yeah, there is a lot of evidence of a lot of water on Mars. And one of the real questions that I suppose to tie it back to this work is there's evidence on Mars of these catastrophic floods, where we might have had a dam that broke and just flooded a huge valley sort of thing. There are these canyons that are massive, and theories are that they could have been created very, very quickly. And this is something that when we landed at Jezero Crater, there were people who were estimating how long did it take to deposit this delta. And based on a whole lot of different observations, the time estimate was anywhere between 1 minute and 1 million years.
Wow.
So now I think that with finding out that we have different things deposited at different depths over a long time, we needed at least enough time for these rocks at the bottom, for the sediment at the bottom to turn into a solid rock while it was still wet. So this extends out this time to a time which is most likely long enough to have life take a hold, which happened very, very quickly on Earth as soon as it was able to.
That's Michael Jones from the Queensland University of Technology. And this is SpaceTime. Still to come, NASA's Lucy mission successfully completes its close encounter flyby of the main belt asteroid Donald Johanson. And later in the science report, how changes in diet may have played an important role in the origins of Homo sapiens. All that and more still to come on SpaceTime. NASA's Lucy spacecraft has successfully completed its close encounter flyby of the main belt asteroid Donald Johanson. The first stunning images are showing a weird, uniquely potato-shaped asteroid that formed around 150 million years ago. The images were collected as the spacecraft flew just 960 kilometres above this ancient world. Earlier observations had suggested large brightness variations over a 10-day period. So some of the Lucy team members' expectations were confirmed when the first images showed what appeared to be an elongated contact binary, that is, where single objects formed from the collision of two smaller bodies. However, mission managers were surprised by the odd shape of the narrow neck connecting the two lobes, which looks like two nested ice cream cones. Lucy mission principal investigator Hal Leveson from the Southwest Research Institute in Boulder, Colorado, says asteroid Donald Johanson has a strikingly complex geology. He says as the body's complex structures are studied in detail, they'll reveal important information about the building blocks and collisional processes that form the planets in our solar system. Based on a preliminary analysis of the first available images collected by the spacecraft's LLORI imager, the asteroid appears to be larger than originally estimated. We now think it's roughly 8 kilometres long and around 3.5 kilometres wide. It'll take up to a week to download the entire close encounter data from the spacecraft. Back in November 2023, Lucy successfully observed the tiny main-belt asteroid called Dinkinesh at its contact binary moon Salim. And like Dinkinesh, Donald Johanson isn't the primary science target of this mission. The Dinkinesh flyby was really a systems test for the mission, while this encounter is more of a full dress rehearsal, during which mission managers are conducting a series of dense observations to maximize data collection. The data collected by Lucy's other scientific instruments, the L. Ralph Color Imager and Infrared Spectrometer, and the LaTeSS Thermal Infrared Spectrometer, will be retrieved and analysed over the next few weeks. Donald Johanson is likely a member of the Eragon collisional asteroid family, a group of asteroids all on similar orbits that were created when a larger parent body broke apart. The family originated in the inner main belt, not far from the source regions for the near-Earth asteroids Bennu and Ryugu. Bennu was recently visited by NASA's OSIRIS-REx spacecraft, while the Japanese aerospace agency JAXA's Hayabusa 2 mission visited Ryugu. Donald Johanson is named after the paleontologist who discovered Lucy, the fossilized skeleton of an earlier Australopithecus hominid found in Ethiopia back in 1974, which is how the Lucy mission got its name. The Lucy spacecraft will now spend the remainder of this year travelling through the main asteroid belt between Mars and Jupiter. Lucy will encounter the mission's first primary target, the Jovian Trojan asteroid Euripides, in August 2027. Trojans are asteroids that travel in the same orbit as a planet, usually about 60 degrees ahead and behind the planet as it orbits around the Sun. These locations are known as the L4 and L5 Lagrangian points. Lagrangian points are named in honour of the Italian-French mathematician Giuseppe Louis Lagrange, who was working on the general three-body problem in orbital mechanics. They're points in space where the gravitational pull of two bodies, such as the Sun and the Earth or the Earth and the Moon, tend to cancel each other out, while at the same time equaling the centripetal force needed for a small body to move relative to the two larger bodies. In the process, this allows the smaller object to remain there for an extended period of time. There are 5 Lagrangian points, known as the L1, 2, 3, 4 and 5 positions. L1, 2 and 3 are all along a line connecting two bodies, say the Earth and the Sun. L1 is between the Earth and the Sun and is often used by spacecraft needing an uninterrupted view of our local star, such as the Solar and Heliospheric Observatory satellite SOHO. The L2 position is on the opposite side of the Earth to the Sun, and it's home to spacecraft like Planck and the James Webb Space Telescope. And it's ideal for astronomy as the spacecraft are still close enough to communicate with the Earth while keeping the Sun behind them for solar power and still providing a clear view of deep space for telescopes. The L3 position is on the opposite side of the Sun to the Earth. Because the L3 point is always hidden from Earth by the Sun, it's popular in science fiction as the location for a hypothetical second Earth. The L4 and L5 positions provide stable orbits around 60 degrees ahead and 60 degrees behind Earth's orbit as it goes around the Sun, and these are where Trojan asteroids are commonly found. Launched back in 2021, Lucy's undertaking a 12-year mission covering some 6.5 billion kilometres, in the process of visiting at least 7 asteroids. The Trojans are left over from the early days of the solar system's formation 4.6 billion years ago. Effectively, they're fossils of the planetary formation process, and therefore they hold vital clues to decipher the solar system's early history. And so, just as the Lucy fossil provided unique insights into the origins of humanity, the Lucy spacecraft promises to revolutionize science's knowledge of the origins of humanity's homeworld. The mission will provide an unparalleled glimpse into the formation of our solar system, helping astronomers better understand the source of volatiles and organics on terrestrial planets, as well as the evolution of the planetary system as a whole. This is SpaceTime. Time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study warns that heart-related deaths are significantly more common during overnight heat waves. A report in the journals of the American College of Cardiology looked at heat waves involving elevated temperatures that persisted throughout the day and overnight. The authors looked at data from 2.4 million heart disease deaths from mainland China over a 6-year period. And they compared deaths from daytime only, nighttime only, and day-night compound heat waves. And they found that the risk of death increased steadily with the length of the overnight heat waves, while daytime-only heat waves only had an increased risk after specific thresholds, which tended to plateau out at moderate levels. A new study has found that changes in diet or the way food was processed may have played an important role in the origins of modern humans. The findings, reported in the Journal of the Royal Society Open Science, show that early hominids couldn't generate as much bite force in their molar teeth as their ancestors. The authors say Homo habilis, the earliest members of the genus, lacked the ability to process food requiring strong molar bites, unlike the Australopithecines that came before them. They say that dietary and food processing changes likely played an important role in the emergence of modern humans. 2 new studies looking into the origins of the domestic house cat have pinpointed Tunisia as a likely starting place. The studies by the University of Rome Tor Vergata and the University of Exeter examined both genetic data and archaeological evidence. The family kitty cat likely accompanied early farmers from Neolithic times, spreading throughout Europe alongside the adoption of agriculture. Now, the Rome study, reported in the preprint server bioarchive, looked at ancient cat specimens from 97 archaeological sites across Europe and Anatolia, as well as museum samples from Italy, Bulgaria and Northern Africa. The DNA analysis shows that felines with domestic ancestry only appeared in Europe from around the 1st century, thousands of years later than traditional narratives had suggested. They also identified 2 introductory waves. One brought wildcats from northwestern Africa to Sardinia by the 2nd century BCE, in the process giving rise to the island's present-day wild population. And the other, during the Roman imperial period, introduced cats genetically similar to the modern domestic lines we see across Europe and the rest of the world really these days, pointing towards Tunisia as a key centre for early domestication. The University of Exeter study, also reported in bioarchive, analysed 2,416 archaeological field bones across 206 sites, finding domestic cats had already appeared in Europe early in the 1st millennium BCE, and that's well before the height of Roman expansion. Australian identical twins are going viral at the moment following a news interview during which they were seen speaking perfectly in sync after witnessing a fatal crash and subsequent carjacking, during which the armed offender threatened bystanders with a gun.
He went up there and he was coming back down towards us and he goes, "Run, he's got a gun." And our heart started to pound and I said, "Oh, Mum, where's Mum?" And poor Mum was stuck up there.
That's Queensland twin sisters Bridget and Paula Powers. Their amazing behaviour is being put down to a phenomenon known as twin telepathy. But the science tells us telepathy isn't real. So what's really going on? Well, it's all put down to their near-identical genetic makeup, which means monozygotic or identical twins develop similar brain processes, resulting in similar thoughts, similar feelings, and sometimes even similar dreams when sleeping. Twins often finish each other's sentences and think the same thoughts. That has more to do with shared experiences than psychic telepathy. This sort of psychological connection really isn't that mysterious. Any two people who know each other really well and who have shared common experiences, including non-twin siblings, married couples, and even best friends, can complete each other's sentences and laugh at inside jokes that leave outsiders baffled. Put simply, there is no concrete explanation as to how or even why some twins share the same thoughts and dreams, with the most likely answer always boiling down to having a similar genetic makeup and brain structures predisposing them to processing information alike and to think in very similar ways. The simple fact is, there are about 100 million twins around the world, and most do not report experiencing any sort of mysterious telepathic connection. Tim Mendham from Australian Skeptic says if a psychic connection between twins was as strong and common as often claimed, then simply by chance alone there should be millions of these accounts, and not the mere handful we hear about.
Yeah, there's probably two aspects to it, actually. One is a sort of natural, social, family thing, and the other one is what a lot of psychic proponents put forward, that twins know what's happening with each other, and even over long distances, etc. One's in trouble, the other one feels it, etc. It raises like two skeptics, right? It's sort of, I know an example of, people would say. The concept is twin telepathy. Now, the term telepathy is a problem for a start. But anyway, there is the suggestion that people who are what's called identical twins, which is monozygotic twins, which is from the same fertilized egg sharing the same DNA. So the people are very similar. They look alike, they sound alike, they have the same build, etc. This is the sort of twins that you find hard to tell apart unless they're wearing different socks or something. These are people who do think very similarly, especially if they're brought up together in the same environment, often treated together as a unit. And there are many examples of this. They will sort of either complete each other's sentences or even overlap with what they're saying, almost identically to the word. We've seen this recent example of these two people who are talking to the media.
But couples do this as well if
they do. I was going to say, yeah. And so you don't have to be a twin, but if you're in each other's pocket for a long period of time, you do tend to understand and think what their attitude is, whether it's the same as yours or not. You know what's going to happen. And therefore you can sense when, hang on, someone's not here, they should be here. They're normally here. Where are they? You walk around and you find them in a different room. Yeah, it does. I mean, anyone who's been married for a long time gets that feeling that you get to know the other person so well, you almost can start a topic halfway through and they'll understand what you're talking about.
I think it was the synergy of the conversation that got everyone so excited when they saw the...
Yes, I mean, and you know, it was so dramatic with them that they were sort of... There was at times where one was slightly behind the other, like a half a word or a word, and that's almost like a hint as to the word they're going to say. But at other times they were talking over each other and basically saying the same things, and sometimes in decent detail, enough that you think, well, that can't be coincidence. Well, it's not. It's because they think the same way and they say the same words, and they've been doing this all their lives. I've heard of examples, I haven't seen many, I must admit, but I've heard of examples of people who claim they do exactly that. So it's not just this pair of twins on the TV media being interviewed. It happens in other places. It's rare, but it's not incomprehensible. So there's nothing you need to sort of put any special twist on it to say why it happens. Then you get the claims of people who say that twins are linked telepathically and that they know exactly what's going on with someone, even if they're in different places. That might be because if they're in the same area, same house, for instance, they're normally in one place and you say, you know, where are they? They're normally here. They're not here. Where are they? So you go look for them. But people on the other side of the world, it's very hard to get real, reliable examples of that happening. And anecdotal evidence is not good enough for that sort of thing. You have to put it to the test.
Yeah, there's the famous case of the twin girls, one of whom was drowning in the tub, apparently. But as it turns out, she had a history of having fits in the tub. So consequently, when she didn't return when she was supposed to, then people knew something was going on that shouldn't have been going on. And that's why they went up and checked, not because of some ESP.
No, because they weren't there at the right time. And the time you normally expect them to be. And twins work together. I think that example was in the one house where someone said, "Where is so-and-so? Oops, bath, oops,"
Yep, exactly
they
right.
Epilepsy, an issue. So, you can do a test of, say, twins that are brought up separately, which is rare. It doesn't happen a lot, to see if they have differences of approach, etc. Or twins who were brought up together, but put them on other sides of the world and see if they, do a proper parapsychology test. People who go through this twin telepathy tend to get over it after a number of years. They do tend to develop their own way of thinking and their own approaches. And some carried on. This particular example we saw on the TV interview, they were in their 40s, I think, and they had been doing it all their lives.
Apparently the synergy wasn't there when they were school kids. It only developed over time.
If they are that have the same attitude, will sort of separate out when they get their own lives. Others will go the other way. Perhaps, they don't marry or something and they link better to each other. They bond stronger with each other. It's an interesting experience. It's not unheard of. There are other examples. So, this particular one on the TV has gone viral as if it's the only time it's ever happened. It's not.
That's Tim Mendham from Australian Skeptics.
They laugh alike, they walk alike, at times they even talk alike. You can lose your mind.
And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.